Yeah, hi. Welcome to space.com. NASA flyby of Jupiter's big moon Ganymede reveals auroras and huge unknown craters. After a NASA mission passed within 620 miles of Jupiter's largest moon Ganymede in June 2021, scientists are still decoding what the encounter can teach us about a strange world. Two missions have previously imaged Ganymede, the largest moon in the solar system. Voyager 1 mission in 1979 and the Galileo spacecraft in the mid-1990s. Some of those images, however, were taken at a less than ideal angle, leaving large blank spots that scientists knew nothing about. Technology has also improved dramatically since those missions launched. So scientists were thrilled when NASA's Jupiter explorer Juno revealed the moon's crater-covered surface in the greatest detail ever and spotted shimmering auroras stretching between Ganymede's poles and equator. These images outlined a plethora of new features on Ganymede's surface, including impact craters, electrical discharge impact craters as large as 60 miles wide. Jeffrey Collins, a geologist at Wheaton College in Massachusetts, said the Lunar and Planetary Science Conference that took place on 7th to 11th in Texas. We missed some really big impact craters that we just couldn't see in the Voyager data, Collins said. This should be a cautionary tale for trying to map things off just like one image with one lightning angle. One viewing angle. We missed this big 100-kilometer crater that's really obvious on the Juno cam data, and another, a little less obvious crater that is about 110 kilometers wide. The images also revealed several smaller craters, 25 to 30 miles wide. It's funny how they change between miles and kilometers. Have you noticed? And multiple features, and the scientists believe might be a result of Ganymede's volcanic activity. We have found caldera-like features, similar to those that we have seen previously in other parts of Ganymede. Calderas are volcanic craters that, in the case of Ganymede, were likely created by cryovolcanoes that spout frozen water and gas from the moon's interior. Yeah. Do a discharge event. The number of these features seen in the June images suggests that much more intense volcanic activity on the moon than scientists expected previously. Yeah. Or it's just, like I said now for the last time, electrical discharge events. And obviously something electric is going on because we have auroras. Still. So probably we will have much bigger auroras there soon too. This actually bumps up the number of total caldera-like features that we found on Ganymede by 30%, said Collins. It definitely makes us think that we have undercounted these so far. There might be a lot more of these to be found on Ganymede as we get new data. Not only is Ganymede the largest moon in the entire solar system, 26% larger than the planet Mercury, it is also the only moon that we know has its own magnetic field. The variations in this magnetic field led scientists to conclude that the moon must have a massive underground ocean of salty water, which is up to 60 miles deep and hidden underneath a 95-mile thick, 150 kilometers crust of ice and rock. The ocean makes Ganymede a prime candidate for the existence of primitive forms of life. Orbiting at 665,000 miles away from the gas giant Jupiter, Ganymede is embedded within Jupiter's magnetic field. And enormous gravity, which attracts passing asteroids and comets. Or it's just its magnetic field, which reacts with those passing asteroids and comets. Like Earth does. The interplay between the magnetic fields of Ganymede and Jupiter gives rise to bright auroras on the former the only such displays ever observed on the moon. Ganymede's auroras were discovered in images from the Hubble Space Telescope, but the recent Juno flyby enabled scientists to gain more insights into these shimmering spectacles. Spectacles. We were now able to see the exact locations of the auroral emissions. Emissions? How can there be emissions? Anyway, Pippa Molyneux, a researcher at Southwest Research Institute in San Antonio, Texas, said at the conference, we were able to see the latitudinal extent of the aurora for the first time. And we see that there are very sharp boundaries at the polarward edges of both aurora ovals, whereas when you move towards the equator, the emissions fall off more gradually. So, future models would have to explain this. It's a Birkeland current. Ganymede will be the main target of the upcoming European Jupiter Icy Moons Explorer 2, which is expected to launch next year. Yeah, let's see how much they launch next year. But anyway, I thought it's interesting. Auroras on the moon. Yeah, this is our star. I don't know how fresh that's. We have to expect whatever now from the sun. Thanks.